This is our solar system to scale. To scale means that it is the same distance in relationship to its size. So in other words, if we take our sun at its full size and all of our planets and then shrink everything down, everything will be shrunk down by the same number. And at that tiny size comparative to our actual sun, everything will be the same distance away in relationship and the same size in relationship. So with that, we're going to look at how everything plays together. It's sometimes weird to me and boggling to me that the planets just sit there and orbit around the sun. I wonder why they don't just float away. And one of the things I know is that the sun's gravity kind of keeps things close. But then if the sun's gravity is keeping things close, why don't they just float away? So what I'm going to do today is I'm just going to investigate what's happening with our solar system. And since everything is orbiting the sun, I'm going to just start playing with our sun. And so if I come here and I click on the sun, right here, this is going to tell me that the mass that's happening here is equal to the mass of our current sun. So I can actually adjust that and make the mass, or how much the sun is made up of, doubled in size. I can triple it in size. I can even make it zero its size, right? I can make it so that it disappears. So let's just start playing with this. And I'm going to switch its mass to 2 times its normal size. So I'm going to click on that. And when I do, I want you to watch what's happening to the orbits and what changed. So with that, before I do, kind of think about what do you think is going to happen if I make it 2 times as big as what it is right now. So we just are going to double the size of the sun. Okay, let's do it. Watch carefully. Is that what you predicted would happen? If not, how is it different than what you predicted? Take notes about how the shape and changed, how the orbit shape changed. Okay. That's fun, right? So let's zoom out, check on our planets out here. Okay. So there's definitely some change to their orbit as well. Remember that these lines aren't actually visible in space. They are just to help us see what the orbit is. Okay, so let's reset this. So I'm going to go and reset our solar system so that the sun is equal to 1 again. Okay, so sun is equal to 1. I'm going to get it so that we can see it. And let's take it up to 5 times. So let's do 5 times the size of our original sun. Okay, so I'm going to press enter and watch carefully what happens. I'm going to just zoom out just a little bit so we can see. Here we go. Is that what you expected to happen? I'm going to zoom in. So I've increased it by 2 times and I increased it by 5 times. What I want you to think about is how did that affect the orbit, and how did that affect the gravity of the sun? Okay, let's reset it one more time. And this time let's do 10 times. So I'm going to click on our sun and click done there, and let's go to 10 times. Here we go. Oh, I'm zooming in, I apologize. Oh, sorry. So what happened? I'm not zooming anymore. This is just what's happening on the screen. I am going to zoom in back to our center. What happened? Our sun no longer is our sun, and now is the sun nova remnant. So when we increase the gravity or the mass 10 times the size of the sun, what happened? Okay, I'm going to go back and I'm going to reset our solar system. There we go. Okay, so I just showed you what happens when I increase. I want you to think about what would happen if we decreased the mass of the sun. And I want you to kind of just ponder that and kind of come up with your prediction. And then you'll share that in your notes. Thanks.